All right, let's redo this example of snow cones found on page 298 in your textbook. Write an equation relating the number of snow cones sold and the money spent on cups. Okay, so what we see here is a huge list of stuff. Cones sold, the number of cups that you use, the cost for those cups, or the cost for 100 cups apparently, the ice that you use in ounces, so what you'll need to run this popsicle stand, the cost for the ice, the syrup, the cost for syrup, fixed cost, probably like, your wheelie cart thingamabob, your, it's not a food truck, but it's a snow cone truck, whatever. And the revenue. It's probably a per month situation here. Nonetheless, number of snow cones sold. I'm going to call that N. I'm going to simplify that to number of cones sold. And money spent on cups. I'm just going to use C for cups. Cost of cups. C equals cost for cups. Now, for every snow cone we sell, we're going to put it in a cup, and the cups are $1 for 100. So for every 100 that we sell, we spend $1, which means that each cup is really a penny. And then we sell N of them, and so we have to buy N of them. So let's see, the cost for cups. C is going to be, well, let's see. The cost of cups is actually our response variable. It is responding to how many cups we actually sell, whatever. So this is our explanatory. However many we need, that explains however many we should buy or spend on. So the cost for the cups is going to be, let's see, the constant change. So notice that this is going up by $1 every time, but this is not going up by $1. It's going up for 100 cones, snow cones. So the change in the cost of cups, so the change here is $1 for every 100 cones sold. So our ratio between the change in the response variable and the change in the explanatory variable is our constant rate of change, and that is $1 for each 100 cups. And then that needs to be multiplied times however many cups we need. So we are spending a penny N times every time we sell a cup. So if we rewrite this, $1 for 100 cups, that's like a penny per cup. So 0.01 N for the cost for the cups. Be sure to clearly write what each variable represents. Done. Check. Write an equation relating the number of snow cones, okay, I'm still going to use N for that, and the amount of syrup. Okay, so boom, boom, boom. Number of snow cones and the amount of syrup used. Okay, so we are relating N. We're not doing it to this. What do we want to call this? Should we call this, I don't know. We'll call this S for syrup. Okay. So let's see. N equals number of cones sold. Okay. And S equals ounces of syrup. Ounces of syrup that we're going to need. So the ounces of syrup. Let's see what our rate is here. Well, for every 100 cones sold, we use 200 ounces of syrup. Oh, okay. So just so that we're crystal clear here. So this would be the response. The amount of syrup we need is responding to how many cones we sell. Excuse me. So the change in the response variable is 200 ounces. So here's our ratio for each 100 cups. Okay, and we will multiply that times however many cups we sell. Got it. What is that? That is like 2 ounces per cup. If we have 200 ounces for 100 cups, then that is 2 ounces for each cup. So 2N. Where this is not cost, though, this is just pure and simple. How many ounces of syrup do we need on hand? If we're going to sell 100 cups, we need 200 ounces on hand. If we're going to sell 500 cups, double that, we need 1,000 ounces on hand. And this 2 represents it's 2 ounces per snow cone of syrup. Got it. 3. Write an equation relating the number of snow cones sold, N, and the money spent on syrup. Ooh. What should we call this? I can't call it S. I can't call it C for cost of cups. I can't call it S for syrup. So I'm going to call it, I don't know. I'm going to call it, I guess cost of syrup. CS. Okay. N equals number of cones sold. And CS equals cost for syrup. CS is going to be, okay, well, let's see here. For every 100 snow cones sold, it costs us $4. Okay, which is 400 pennies. It's like 4 cents. So going back to this being 1 cent a cup, this is like 4 cents a cup. Okay, so let me write that down. Is like having $4. So the cost is $4 per 100 cups. There's our ratio times the number of cups we sell. And 4 divided by 100 is 0.04 or 4 cents. Okay, so there is our equation for money spent on syrup. Write an equation relating the number of snow cones sold and the money spent on ice. Well, at least I can use I for ice, but it's money. So it's not how much ounces of ice do we need, it is just the money equation here. So I'm still going to let N equal number of cones sold. And now I'm going to let I equal the cost for ice. Okay, I've kind of gotten the hang of this. This is $7 for 100 cones sold, so 7 cents a pop. $7 for 100 cups times the number of cups we are selling. 7 cents N times is the cost there. Write an equation relating the number of snow cones sold and the money spent. Include cups, include syrup cost, because this is money spent, so not just syrup, but syrup cost. That's this one. Ice cost and fixed cost. Okay. So this fixed cost, I notice, it doesn't matter how many cones you sell. You have to, this is like your flat, you have to pay this every month. regardless of what you do. Maybe you're getting a license to be in the park. Whatever it is, that's your fixed cost. Right. Okay, so we are going to need to include the cost for cups. Let's call this TC for total cost. That's too light. Let's go N equals number of snow cones sold. TC equals total cost. TC is, okay, well, we have a cup cost. That is a penny for each, so 0.01 N. We've got an ice cost. We found that. That was 7 cents a pop, 0.07 N. We found, okay, that's money. Here's money. Syrup cost. Syrup cost was 4 cents per cup, 0.04 N. And, okay, so we got cups, we've got ice, we've got syrup, and we've got our whatever it is, fixed cost. So plus $245. It doesn't matter how many you sell, that is always going to be your fixed cost. Okay, so your total cost, $245 initially, plus, okay, let's see, 7 cents, 8 cents, 12 cents per snow cone you sell. Okay. How many snow cones need to be sold in order to have more revenue than cost? Ooh, let's look at the revenue. The revenue is what, $75 for 100 snow cones sold. Okay, so first things first, revenue, the money coming in is, okay, the rate was $75 per 100 cups. $75 per 100 cups sold times N. Okay, so just so that we're crystal clear, for all of my initial values in terms of my y equal the response equals the initial amount plus the constant rate times the explanatory variable. Notice that my initial amounts have all been 0 except for the fixed cost. So same here, the initial amount was 0 plus the constant rate times the number that we're getting. Well, what is 75? What is that? 3/4 or 0.75? Okay. Oh, that's nice. So the revenue that comes in from every snow cone is 75 cents. And the cost for every snow cone is 12 cents. And then there's this flat fee here. So how many snow cones need to be sold? Well, I'm going to start trying some values. Let's see here. I need my calculator. Got it. Right. For fun, let's suppose that we sell 100 of these. Well, if we sell 100 of these, then we only make 75 bucks. And now I got to tell you, the fixed cost alone, you know, we got to drown out that fixed cost. So we have to at minimum start at 400 snow cones. Yeah. So let's check to see if 400 snow cones will do the job. Okay, so let's suppose for fun, let's go N and total cost. If we sell 400 snow cones, then, oh, here, let's go total cost and let's go revenue, yeah? The total cost will be $245 plus 12 cents times 400 snow cones made. Total cost, $293. The revenue, 75 cents times 400. I think we already know that. It's up here in the chart. It's 300. Ooh, that's really close. So this is actually really, really close. The revenue is a little bit more, so we can probably, we could decrease, actually, the number of snow cones that we have to sell in order to break even. I don't know. Let's try 380. Just for fun. So, the total cost would be $245 plus 12 cents times 380 would be $290.60. The revenue here, 75 cents times 380 snow cones sold, 285. Now, we dipped a little too low. Now the revenue is below the cost. So we have not broken even yet. We're still at a loss. So, I don't know, let's narrow it down. Let's go 390. Okay, so 245 plus 12 cents for each snow cone and 390 snow cones. $291.80. And now we'll go, oops, we'll put it in here and say, well, each snow cone gets 75 cents, so 0.75 times 390. We get $292.50. Ooh, that's more. That's more. We're getting closer, but this was a little high. So let's go 386. Narrowing this down. 245 plus 12 cents times 386. $291.32. The revenue, what was it, 386 of these at 75 cents. $289.50. Wow, that's so close. The revenue was just under, so we need to go a little bit higher. 388, I'm gonna guess. All right, here we go again. So $245 flat fee plus 12 cents times 388 of these, $291.56. And now 75 cents times 388 of these, $291. So I'm just going to check 387 really quick, because I'm wondering if it's perfect or if it's not perfect. It is not perfect. So it looks like this is where the total cost is a little bit more. So I really should have checked 389. Okay, I'm checking it. I'm really going to plug in, okay, 389, just to be super sure. So this would be $291.68, and the revenue would be $291.75. Oh, there you go. That's super close to each other, but we are out of the red zone. We are no longer in debt. At 388 snow cones, we were in debt by 56 cents. But at selling 389 of them, we have gone above by what, 7 cents? Yay! Okay, so breaking even. Sell at least 389 snow cones. Okay, to stay out of debt, basically. Okay, so overall, here's what we wanted to get at in this section, yeah? Let's see, compute and interpret the slope of a line. Well, slope, doing it repeatedly. Slope, constant change is slope. And we just kept doing it over and over and over again. This slope, though, what did we have in this one? We had the worth of a depreciating copying machine. We had tickets that started at $1 and they kept increasing by 50 cents. That was the slope there. We had the cost of some pizzas. It was $4 per pizza. And then on this one, we had a lot of slopes. Cost for ice, cost for cups, cost for syrup, total cost. Like we had all kinds of, well, no. Total cost also had a y-intercept, an initial amount of 245. Now, interpret the y-intercept of a line. In this one, we actually discovered that the initial value is the y-intercept, also known as the b. And that, to me, is, so back to here, right, is always this initial amount, and then you have the constant change, which is your slope, times however many times you make that constant change, which is however many times your explanatory variable changes. So, and then we said write the equation of a line in slope-intercept form. Back to this. When we're thinking about it in terms of a given situation, it's easiest for me to think it's the initial value plus or minus the constant rate of change or the constant change times however many times it happens, which is the number of the explanatory variable. And that if you rearrange this, you get y equals mx plus b, where m is the rate of change, x is the explanatory variable, and the initial is the b. Yes? So we use the slope, which is the ratio of change. We use the y-intercept, which is the initial value, and we use that to write our equation of the line.